Welcome to my channel guys, Fresh Engineers. Hope you like my new logo. This I have designed using AI Portal. So welcome to my channel once again. So guys, what we will be learning today? We will be learning about die-off controllers. What are die-off controllers? Die-off controllers are the generator set controllers which are highly advanced modules which are used nowadays for controlling not only controlling the generators but also synchronizing and power management. These were early only used for generator purpose, but nowadays they have been used along with solar panels and batteries. Let's see what we will be learning today. We will be learning today different types of die-off controllers. As I told earlier, we'll be going through a brief description on what these controllers are. Then our main AGC4, that is genset controller, automatic genset controller. We will be seeing two parts, the hardware part, that is the display, and the electronic control unit. Afterwards we will see the operation of the display, and then finally we will be seeing the terminal details of ECU. Okay, so guys, let's see different types of die-off controllers. The first one being the same AGC, automatic generator controller. These are worldwide used. Die-off is a Danish company which makes these controllers. So AGC is a general purpose generator controller which not only controls the generator but also is used in power management and synchronization. Second comes solar controllers. ACS solar controller, automatic solar controllers. These synchronize our PV panels with the generator, and also in this way it tries to maximize the solar consumption and reduce the generator consumption. Also it can be used with the mains. Then comes battery. So these have these controllers charge the battery and keep it ready in case of some power cuts, so that your system is sustained. These can be used along with the other two controllers and is independently handle the load. During the generator or solar availability, these batteries are charged, and during non-availability, necessary emergency loads can be supplied through this controller. Then comes hybrid. AGC hybrid, that is mainly this controller is a hybrid one. It can be used for both solar as well as generator sets. So guys, as you can see, this is the display unit which AGC4 uses. So in this I will be explaining you various aspects of this. So this is the display which gives all the details of the unit. Okay, so if you see, this is an LED, alarm LED. So if there is any alarm at the generator side or in the bus, you will get a green indication, and this will not allow you to start the generator. So in case now alarm has come and you want to know what's causing your genset not to start, you have to press this button, info. This will give you detail of all active alarms. Then from there you can reset it. So this button is called jump button. When you have to edit any parameter in the controller, you have to press this, and you should also be knowing the number of the parameter which you want to edit. So usually you have thousands of parameters in the controller, so people usually use this when they want to edit a particular without wasting their time. So as the light indicates green color, start button is to start your generator. Pressing it starts your generator from the panel. Similarly, stop button, this stops your generator once pressed, but there is a cooling time which avoids it from immediately switching off. If it is set to 0, then your generator will be immediately stopped. So as you see, this is a green LED run button, run indication. This becomes green when you have the generator running. So once your generator starts and the controller checks whether the voltage and frequency are healthy, then this light glows. This light gives you permission to go to either you can synchronize or close the breaker. So this switch is given to close the breaker. Once you press, if you are synchronized, it takes time delay and it matches the voltage and frequency, and then it closes the breaker. Once the breaker is closed, you have this LED glowing that you are now connected to the load. So this button, mode button, is given to select the type of mode which you want the controller to operate in. There are 3 modes. One is manual, where you do not control the voltage and frequency from the diaph, but you can start stop from diaph. Then the second mode is semi-auto. In semi-auto, you control the generator from here, but the starting and stopping of the generator is again in your hands. It's not automatically happens, not based on the load demand. Third one is auto. Based on the load requirement, the controller itself can take a decision to start the generator. So this light indicates whether your generator is in auto mode or not. So this is alarm bypass indication. If you have bypassed any alarm in the settings, this light will be active. When you start the controller checks itself and gives you a healthy indication if all the internal components are okay. So this is a power. If there is power given to the controller, that is 24 volts, this light will be healthy. Without this light the controller will not start. So these are the selector switches like cursor, where you can navigate through various pages. And apart from that, you have view. These 3 views will give you various parameters which you can use by shifting the cursor tree and then pressing select. This is a lock button which gives you indication of all the locks which have happened in the controller. So guys, I'll be explaining the electronic control unit. So before, let me explain you the various communication ports. So this is the display. As you have seen the display backend will be connected to this, through which it will communicate with the display unit. This is service port. You can use a normal USB cable to connect the computer and the controller. This is for taking backup. So this is Ethernet port. Usually you will be having a CAN bus communication to communicate with the various other ECU units in case of paralleling. So let me explain you the various terminal details. These 1 to 28 are actually this one pin 1 and 2 are the power unit. You can give from 8 to 36 volt for the controller. It acts as a power for the controller. So then apart from this has a output relay which gives the status of the controller, whether it is healthy. Then it has 5 relay outputs, 2 PMW outputs and 5 digital inputs. So this is an optional card, and this has all types of communication. If you are using Modbus protocol, then you can connect it here. Like for the solar controller required to control the solar inverters, so Modbus communication used. Apart from this, CAN bus communication, from here also you can use the CAN bus communication. So these are the outputs, various outputs and inputs, like input from the panel that your breaker is healthy, the breaker is closed, and outputs to close the breaker. All those things you can give it from the terminal 37 to 64. So this is your major part. So this is outputs and inputs majorly used to control your governor, the speed of the generator and the voltage AVR. So it can be configured to use as voltage output and also PNW. So these three terminals are very important. They are used for measuring the voltage and current. The first three are used for measuring the current. This is used for measuring the voltage of the generator, and this is used for measuring the voltage of the bus, three phase plus motor. So if you want to control your generator from the controller, like you can get feedback of speed, you can have all the temperature feedbacks, temperature sensors, all these things you can connect it here. You can also have the communication from your engine electronic port to ECU. So this is a different input which is used mainly for like measuring the ambient temperature, all or getting power feedback, all those things you can use. Thank you guys for watching my video. If you like the video, please do subscribe. Thank you.